So I'm starting off on some theory of stability. GZ curve. It's also called as curve of statical stability. It's also called as moment of statical stability, cos and mos. So whether we are talking about cos, curve of statical stability, or we are talking about moment of statical stability, or we are talking about GZ curve, we are talking about the same thing. So curve of statical stability, moment of statical stability, GZ curve. We're talking about the same thing. Okay. Now, what exactly is a GZ curve? So this is theta, the angle of heel. This is corrected GZ in meters. Corrected GZ in meters. So theta will be 0, 10, 20, 30, 40, 50, 60. ठीक है? Shall I move ahead?
Yes, sir.
Okay. So you can write down a GZ curve is a curve drawn by a chief officer with theta as the angle of heel along the x-axis, with theta as the angle of heel along the x-axis, and corrected GZ in meters along the y-axis, and corrected GZ in meters along the y-axis. A GZ curve is dependent on W, that is displacement, and or
So depending or depends?
dependent. GZ curve is dependent on W, that is displacement, and or and oblique or kg of the vessel. Kg of the vessel. If any of the two values change, if any of the two values change, the GZ curve will change. the GZ curve will change. Hence, it is condition specific. Hence, it is condition specific. Okay. Info obtained from GZ curve. What information do we obtain from GZ curve? First one is GZ max, maximum GZ. This value gives me the GZ maximum. Whatever I read off on the y-axis. Second, angle of heel at GZ max.
So, angle of heel, sir.
Angle of heel at GZ max. Angle of heel at GZ max. Angle of heel at maximum GZ. This is angle of heel at GZ max. It can be anywhere around 40 degrees. Can be 45 also, can be 40 also, anywhere around that for our merchant ships. Angle of heel at GZ max. Angle of vanishing stability. Angle of vanishing stability. Angle of VS. Angle of vanishing stability. This angle is called as angle of vanishing stability. So approximately, let us say, equal to 75 degrees. How do you define it? How do you define angle of vanishing stability? It
So
is
where it started becoming negative?
So write down, it is that angle of heel, it is that angle of heel at which the GZ becomes zero again. It starts from zero. When it becomes zero again, that angle of heel at which it becomes zero again is known as angle of vanishing stability. That means the stability has vanished,
At at which GZ curve becomes zero again, sir.
at which the GZ becomes zero again,
Okay, sir.
at which the GZ curve becomes zero again, at which the GZ becomes zero again, same thing. At which the GZ curve becomes zero again, also the same thing. That means there is no more writing lever left for the vessel to come back. So इसके बाद में vanishing stability पे vessel capsize कर जाएगा. इसके बाद डूबेगा for sure, because it has lost its own inherent ability to righten back. It has lost its own inherent ability to righten back. So it will capsize. Range of positive stability. Range of positive stability. ROPS. Range of positive stability. ROPS. Range of positive stability is angle of vanishing stability minus angle at point of origin. In this particular case, which I'm giving an example,
Sir, point of origin.
angle at point of origin,
Okay, sir.
angle of vanishing stability minus the angle at point of origin. So in this example which I'm giving you, point of origin is 0. So ROPS is equal to 75 minus 0. But supposing my point of origin was 10 degrees, then it would have been 75 minus 10. Whatever is the point of origin, that will become my, whatever is my
So,
point of origin, that
so
will
this
become,
range will be in degrees of heel. That
it'll be in the degrees of angle of heel, correct? This range is the decrease of angle of heel. Basically, this is determining how much of positive stability is left in me, because that will determine my ability to righten back. GM initial.
Sir, 75 degree. Sir, 75 degrees. What it indicates? How much positive stability left in me? That
How much
is
of how much of positive stability is left in me for me to righten back?
75 degrees indicating that.
The the second 75, not the first one. The second 75.
और सर पॉइंट ऑफ ओरिजिन का मतलब क्या हुआ सर एक्चुअली?
पॉइंट ऑफ ओरिजिन का मतलब है कि ओरिजिन मेरा यहाँ पे क्या है, पॉइंट किस, मेरा कर्व कहाँ से ओरिजिनेट कर रहा है।
यहाँ तो सर जीरो ही है वैसे नॉर्मली सर।
माय ओरिजिन, मेरा कर्व कहाँ से ओरिजिनेट कर रहा है, जीरो पे कर रहा है। अगर कोई और कर्व मेरा 10 डिग्री पे ओरिजिनेट करेगा
तो
तो
65
मेरा
हो जाएगा।
तो 65 हो जाएगा, तो मेरी रेंज कम होती जा रही है।
ओके सर।
सर ये 75 को समझा देंगे इन रिलेशन टू हाउ मच पॉजिटिव स्टेबिलिटी लेफ्ट, व्हाट दिस 75 इंडिकेट्स, मतलब उसके
मतलब
रिलेशन में समझा दो सर एक बार।
मतलब बेसिकली जो कर्व है मेरा पूरा का पूरा, पॉजिटिव कर्व जो है, वो कितना मेरी रेंज है उसकी पॉजिटिव स्टेबिलिटी की।
ओके
वो
सर,
भी
ओके
75 है, इतनी मेरी रेंज है जो पॉजिटिव स्टेबिलिटी
ओके
की है।
ओके, ठीक है सर, उसके बाद सिंक हो जाएगा।
ओके, GM initial. GM initial is basically at a fixed value of 57.3 degrees. I erect a perpendicular at a fixed value of 57.3 degrees. I erect a perpendicular. This is a perpendicular which I have erected. Then at the curve, at the point of origin, I draw a tangent to the curve. This is a tangent. This curve has got a concavity up. So I draw a tangent to the curve. The point where the tangent meets the perpendicular, I go left. The point where it meets the x-axis, the y-axis, sorry, that will give me the approximate value of initial GM. I repeat once again. I draw a tangent to the curve at the point of origin. Then from a fixed value, 57.3 degrees, I erect a perpendicular. The place where the tangent and the perpendicular they meet, I go left. Where it meets the y-axis, that is my approximate value of initial GM. Why 57.3 degrees? Because my y-axis is in meters, my x-axis is in degrees. I need to convert the degrees to radian. I know 360 degrees is equal to 2 pi radian, or 1 radian is equal to 360 divided by 2 pi, 57.3 degrees. or 1 degree is equal to 1 upon 57.3 radian. So we take the value of 1 radian, that is 57.3 degrees. उधर से जो टेंजेंट मिलता है उस पॉइंट पे, वो हमें जीएम इनिशियल देता है, अप्रोक्सीमेट वैल्यू। और आगे जाके हम ये वाली वैल्यू जो है इसको यूज करेंगे न्यूमेरिकल में, इसलिए मैंने अभी लिखवा दिया आपको। 1 डिग्री इज इक्वल टू 1 अपॉन 57.3 रेडियन। विल बी यूजिंग दिस वैल्यू आगे जाके। दिस इज द फिफ्थ इंफॉर्मेशन दैट वी ऑब्टेन।
सर
हाँ जी,
सर लेकिन ये से आया कैसे, मतलब कि ये 57.3 पे अगर अपन डाल देंगे टेंजेंट तो इनिशियल जीएम आ जाएगा, मतलब ऐसे कैसे पता लगा हमको?
अभी see, we just have to right now just accept it, because this is your degrees. You can, if you have to convert your degrees to radian, you use this. 360 degrees complete circle is equal to 2 pi radian. So 1 radian is equal to, divide your 360 by 2 pi on your calculator, you'll get this value. So the 1 radian ka value you take on your x-axis, and from there you draw the perpendicular, draw the tangent to the curve. That will give you your, basically, the value, and whatever value you get on the y-axis, that will give you the approximate GM value.
ओके सर।
Sixth, something called as writing moment at a particular theta. Writing moment is a product of displacement into writing lever gz at that theta. So supposing I want a writing moment for 20 degrees, and let us say my vessel is a 50,000 tonner. So 50,000 tons into, at 20 degrees, I erect a perpendicular. जहां पे उसने कर्व को काटा, I go left, supposing it comes as 0.75. So जो whatever is your answer, so many ton meter, that is the writing moment. This is the writing moment at 20 degrees. So what I'm speaking is writing moment at 20 degrees is equal to, let us say, my displacement is 50,000 tons. So 50,000 into the writing lever GZ at 20 degrees. So at 20 degrees, I erect a perpendicular. Wherever it cuts the GZ curve, I go left. Supposing it comes on the y-axis at a value of 0.75 meters, supposing, then the writing moment will be equal to 50,000 tons multiplied by 0.75 meter. Whatever is that product, so many ton meter, that will be the writing moment. Is that okay with everyone?
सर एक बार नंबर 2 सर थोड़ा समझा देना सर, वैनिशिंग स्टेबिलिटी सर।
Vanishing stability is number 3.
हाँ सर, नंबर 3 थोड़ा सा ब्लर हो गया था।
Vanishing stability is when the GZ becomes 0 again. That point at which the GZ curve cuts the x-axis. That is called as vanishing stability.
ओके सर।
Point number 7.
Sir, in this writing moment, why we took 20 degree?
Hanji,
Sir, the writing moment, why we took 20 degree?
just as an example. It can be 10, it can be 20. I just took an example of 20 degrees to explain a point, how to calculate the writing moment.
Okay.
Point number 7. Area under the curve. Area under the GZ curve. Area under the GZ curve have been given. Various areas have been given. So, various areas are there which are given in the stability booklet. So, the vessel needs to meet the IMO's stability criteria. Vessel needs to meet the IMO's stability criteria for various areas which are given under the GZ curve. I'll do this in more detail later. Right now, I'm just writing down one point. And finally, the 8th one is called as dynamical stability, DS. Dynamical stability.
सर एरिया अंडर जीजेड कर्व का एक पॉइंट दोबारा बताएंगे प्लीज।
Area under the GZ curve, I've just written IMO has got some stability criterias. So those stability criterias have been given by IMO. I will shortly be doing them with you. तो उस वक्त जब मैं वो किताब जब हमारे पास स्टेबिलिटी बुकलेट्स होंगी हिंशिप की तो फिर हम उस वक्त मैं ये बताऊंगा इसके बारे में. So stability criteria have been provided by IMO and they are available in the stability booklet. They are available in the stability booklet. तो जब मैं बुकलेट में घुसूंगा उस वक्त मैं ये बताऊंगा.
ओके सर, थैंक यू।
अभी मैं खाली इंट्रोड्यूस कर रहा हूँ उस वक्त मैं इसकी डिटेल्स जब मैं बुकलेट के अंदर घुसेंगे तो देन आई विल बी टेलिंग यू.
ओके सर.
अभी मैं बता रहा हूं डायनामिकल स्टेबिलिटी के बारे में. DS. So write down one paragraph on DS. Dynamical stability. DS is the amount of work done. DS is the amount of work done in bringing a ship to the required angle of heel. DS is the amount of work done in bringing a ship to the required angle of heel. Numerically, it is a product of displacement and area under a curve up to that theta. Numerically, it is a product of displacement and area under the curve up to that theta. Its units are ton meter radian. Its units are ton meter radian. It is used in damage stability calculations. It is used in damaged stability calculation.
सर ये क्या लिखा है? ds theta equals to w into a theta.
Dynamical stability at a theta is equal to displacement into area under the curve up to that theta. इसकी डेफिनेशन हमने यही लिखी है.
जी सर.
It is a product of displacement and area under the curve up to theta. Its units are TMR.
ओके सर.
तो वो आपने इसके बारे में लिख दिया है. It is used in damage stability calculations. This is dynamical stability for you. So all these 8 things together determine what is called as intact stability or stability of a ship.
सर एक वो होता है सर एंगल ऑफ कॉन्ट्रा फ्रैक्चर, ये डेक एज इमर्जन.
वो सब अभी हम कुछ नहीं कर रहे हैं. अभी राइट नाउ आई एम नॉट डूइंग एनीथिंग ऑफ दैट सॉर्ट. अभी पहले इसी को संभाल लें.
सर ये लास्ट सेंटेंस क्या बोला सर आपने?
All these 8 things determine what is called as intact stability of a ship. Intact stability of a ship. All these 8 things, all these 8 factors determine the intact stability of a ship.